Atmospheric phenomena. I have added this section largely because, one, these are cool, and two, because when it comes to our atmosphere, these are probably some of the things that, in some cases, you have seen many, many times and enjoy seeing, and in other cases may not have seen, and if you pay a little bit more attention, gives you something new to look for in the sky. So the thing that most people think of when they think of atmospheric phenomena are rainbows. They're the prettiest, they're most colorful, they're very bright, and everybody enjoys seeing a rainbow. Now rainbows, typically, if it's perfect conditions, have two parts. So the first part, the brightest part, is called the primary. And here in the picture we're seeing part of a primary. And you can see that the colors run from red on the outside through the color spectrum, Roy G. Biv, to violet on the inside. So you've got your red, orange, yellow, green, blue, violet. And so that is obviously in the order from longest wavelength to shortest wavelength, from the outside of the rainbow to the inside of the rainbow. So how does that happen? Well, you need water in the air, and you need sunlight coming from behind you. So you need water in front of you, and sunlight coming in from behind you. So, what have we got happening? Well, we've got a little bit of optics happening here. The sunlight hits the water, and at that point you have refraction. That is the bending of the light by the water droplet. But the amount of refraction depends on the wavelength. So as you can see in the image, blue refracts more than red. And if you included violet, violet would be the most. Then it hits the back of the water droplet. There you get reflection. Then it comes out of the water droplet. You've got some more refraction. And again, the blue is going to get bent more. And so that ends up separating the colors. And so you're going to have violet on the inside of your rainbow and red on the outside of your rainbow. And you'll notice these angles. The angle from where the sunlight goes in to where the violet light comes out is 40 degrees. And from sunlight to red light is 42 degrees. That's always going to be the same. This is why the best rainbows are at sunrise or sunset. Because then the sun is low, and so the rainbow itself is going to be up high in the sky. The higher up the sun is, the lower your rainbow is going to be. So that's a primary rainbow. But you can also get a secondary rainbow. So here's our primary. Here's our secondary. And now the colors are reversed. Now you've got red on the inside of your rainbow and violet on the outside of your rainbow. And the reason is because now you've got 2 reflections instead of just 1 in your water droplet. And so that increases our angle from where the sunlight comes in to where the colors come out. They're going to be spread out more, so it's going to be fainter. And that's why these are typically harder to see, because they are much fainter. So you need just the right conditions of how dark is the sky over here, and certainly the intensity of how much light is coming out of your water droplet. So with 2 reflections, that, I realized I left out L in reflection, that reverses our colors, and it spreads it out more, which is going to give us a fainter secondary rainbow. You can even have a third rainbow, a tertiary rainbow, with 3 reflections in the water droplet, but that's exceedingly rare. So rainbows, everyone has seen a rainbow. But have you seen a halo? Halos occur around the sun. You can also get them around the moon, but those are harder to see. What people often see around the moon is called a, I'm going to get the name wrong, areola, where it's just very bright right next to the moon. That's different. Halos around the sun or around the moon, it's always going to be 22 degrees away from either the sun or the moon. And typically you need cirrus clouds in the vicinity to get a halo. That's because you need ice. And of course, cirrus clouds have ice crystals. And in particular, you need a 6-sided ice crystal, which is what's shown here. And the sunlight or moonlight enters that ice crystal, gets refracted by the ice crystal, and comes out. And as you see, it's always a 22-degree angle, and that has to do with the shape of this 6-sided ice crystal. So here's our sun, go out 22 degrees, which is about 2 fists worth of distance, and all around the sun you will get this halo. Now sometimes you don't get a complete halo, you'll only see maybe an arc over on one side or the other. But getting a nice complete halo around the sun is a beautiful sight to see. So on cold winter days with some cirrus clouds, look around the sun. Don't look at the sun. Look in the vicinity of the sun and see if you see a halo around it. Related to the halo are sundogs. And it's really the same thing that causes a halo. It's still that ice crystals. It's still going to be cirrus clouds. It's still going to be 22 degrees. So that's 22 degrees away from the sun. But here it's more concentrated, and you get a rainbow of colors. Sometimes you don't see the color, you just see a bright spot, but usually you'll see a little bit, at least the red usually shows up pretty well in a sundog. And so here it's just horizontal from the sun. Either side of the sun, you get these sundogs. And then, if the conditions are right, you will get a halo connecting these as well. And I have no idea where the name came from. except that they kind of, stay next to the sun the way a dog does, is my guess. I'm making that up, so don't quote me on that one. A sun pillar. Again, it's ice crystals. Ice crystals do some cool stuff. Whoops, crystals. But now they're reflecting the sunlight in a pillar structure. So this is going to be during sunrise or sunset. And the ice crystals are aligned just right to create this beautiful bright pillar of light as the sun sinks below the horizon. Crepuscular rays. Everybody has seen these, but don't always know what they're called. Lots of folklore about this. But here you basically have dark clouds with gaps, plus dust in the air. So those gaps let the sunlight through. The dark clouds provide the contrast. So you've got contrast of the light and dark. And then the dust particles are what reflect the sunlight so that we can actually see these beams coming down from the clouds. A friend of mine who grew up near the, I want to say Mississippi River. I think that's right. They called these God's drinking from the river. It's God's drinking straws. So lots of different folklore names for these things, depending upon where you live. But the fancy scientific name is a crepuscular ray. So all of these are cool things that you can look for in the sky. All you need to do is think to look up, and hopefully you will see all of these at one point or another.